Hi, thank you for watching my video. I am uploading my videos to share with you what impressed me on astrophotography activities. What you are seeing is a stacked image of the Perseid meteor shower this year. I got this without using any tracking mount. So, I am going to demonstrate how I get this Perseid meteor shower stacked image in this video. The equipment I used was a fisheye lens on a Fujifilm X-pro1 camera mounted on a tripod. This is the time lapse of the frames taken with the fisheye lens. I went to a camping site on this day, and let the camera shoot consecutive 15-second exposures throughout the night. Unfortunately, clouds covered the sky shortly after midnight. The advantage of this method is that I don't have to worry about the polar alignment and getting the right wide-angle frame. Here I show you the comparison of this method, named Fisheye Software Tracking, to the conventional method. The numbers of the total steps are equal for both methods, but as you can see, there are more things done right on site for the conventional method. I have used this small tracking mount, called Nano Tracker. It doesn't have a polar scope, so I have to align 15-second exposure frames while the tracking mount drives high-speed mode. I have to check every frame so that the rotation center of the mount matches to the Polaris, at least as close as possible. After that I have to point the camera with a wide-angle lens on the camera. I hope every time that the frame captures as many shooting stars as possible. Contrastly, the fisheye software tracking method requires just 2 steps on site. I mount this camera with a fisheye lens on a tripod and then start continuous exposures. That's all. Now, what you are seeing is the 360 degrees video of that night. I converted the fisheye frames to this VR-like video. The video is played in the Richo Theta software in Windows Desktop. The screen record is taken using the OBS Studio. I have uploaded previously other videos on how I got a 360 degrees video converted from a circular fisheye format time-lapse. You can find them in the description of this video. Next step would be interesting to you too. I am doing the polar alignment in this VR frame. I built this application using Python and the library called Equilib. I place the mask showing the location of the Polaris and the other stars near the North Pole. Of course I have to rotate the mask according to the date and time at the location on the Earth. I assumed the location was somewhere in Japan, so the time is based on Japanese Standard Time. Just like doing on site in the conventional method, I move the frame up and down as well as translating sideways so that the stars fit in the circles. After I set the polar alignment, I convert the consecutive frames with a fixed time step. In my Fujifilm X-pro1 case, it is 15.3 seconds. That is the interval of the frames of burst mode of 15 seconds exposures. The time lapse of the polar aligned frames is like this. The North Pole is at the top edge. The Earth is moving sideways in this frame. You may think it is similar to the flight map you can see typically for intercontinent flights. The daylight and dark night areas are moving sideways due to the Earth rotation. The principle is the same. Then I selected the frames of the meteor shot. The positions of the stars are fixed in all frames, so stacking is quite easy, but slight adjustment was needed. I used GIMP to do so. Upper layers are stacked in compare blight mode. Finally, stacking frames is done. Here I use the Richo Theta application to show the shooting stars. The shot from Perseid or somewhere close. I hope my idea of doing the process makes sense to you. I spent quite a long time updating the software to do this. I am planning to upload the software to my GitHub page. If you like to try it, please wait for it. Thanks for watching this video. See you next time.